All right, so we're going to continue the notes for the stairs versus towers. So we came up with our graphs, and we noticed that these graphs are quadratic. Okay, they're not exponential, they're not linear, they have that curve to them, and it is not a degree 3 polynomial because we don't have that curvature, that 3-degree curvature. All right, so what did we find from these equations? So what is the relationship that we found between the two when we started this activity? So I remember someone saying that it took, so if we're looking at case 4 here, to build the towers for case 4, we need 3 stairs, or I'm sorry, we need 4 stairs to make a tower. All right, great job. So let's see, let's come up with the equation for the stairs, and then that's going to help us come up with the equation for our towers. All right, so we're going to look at this. This is 2 towers put together. This is 1, 2, 3, 4, 1, 2, 3, 4. So this is a case 4 example, okay? And we're going to stick with this case 4 example to come up with our equations. Okay, and if you notice here, 1, 2, here we also have 1, 2, 3, 4, 1, 2, 3, 4. But if we notice here, we have this guy, and you can actually just cut it in half, right? And then we get even half on one side and half on the other. That is why it has these colors, right? So we're gonna see, well, here we have 5 little squares that make up this side, but over here on this side, we still have 4. And remember, we're thinking about case 4. So when we want to generalize it to be case anything, we want to generalize it to case n. So instead of 4, I'm going to put an n. So this would be n. It doesn't matter what n can be. This can be a 10. This can be a 20, whichever case I want it to be. And because this is n, this side should be n plus 1, right? Because this is 4 and this is 5, which is 4 plus 1. Okay, and all I'm doing is replacing the 4 with an n. Okay, so if we come up with this equation, this side times this side is going to give us the 20 that we need. Okay. So n times n plus 1. But we don't have this whole thing, we just have half of it. So what I'm going to do is I'm going to just divide it by 2. Because if I do that, that gives me this part that I need, which is the stairs. Okay? So we have n times n plus 1 divided by 2. So this is going to end up being our equation for the stairs case. Case n for stairs. Okay, so now let's move on here. So now we could say, okay, this is our equation for the stairs, but how many sets of stairs make up one tower? Well, I know I have 4 stairs that make up one tower. So if I need 4 of them, I would have to multiply that out. Okay, so that means if we need 4 stairs to make up the equation, then I can come up with that towers. I would just have to multiply it by 4. So this is what we're looking at. This is the equation down here for 4 times n. Okay, remember we're working with a case 4, so think about the n being a 4. Okay. But notice it doesn't come together quite the way I want it, because when we do this, we have just one column in the middle. Okay. So for this one here, I would need to get rid of this one right here. I would need to get rid of that one and that one right there in order to make a perfect case 4 tower. Okay, so this is what I did. I took them out. So now this is the 3 columns that I don't need anymore. Okay, and once again, this guy is our towers. Okay. So then I have to think about it. Well, Remember, this is case 4, right? Okay, so I have 3 of them, and it's just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 3 times 4, right? But we're not working with 4, we're working with n because we're trying to generalize it. So there we go. We have our initial, we have 4 stairs. And this is the equation for the stairs. We need 4 of the stairs, but I also have to take away these 3 in order for it to be a perfect stairs, which is, I'm going to take away the 3n. So that is the equation for our towers. So we worked with the stairs, we know we needed 4, and then we got stuck here. We said, oh, we need to get rid of these 3. And these 3 are just 3 of the of 1, 2, 3, 4s. Okay, remember we're case 4, so we replace the 4 with an n because we want to generalize it. So we come up with this guy right here. Okay, and then I can simplify this. So I can distribute my n. So I have 4 times n squared plus n divided by 2 minus 3n. Then here I can cross cancel here. Divide 4 divided by 2 is 2. 2 divided by 2 is 1. So I'm just left with 2n squared plus n minus 3n. Now I can distribute my 2. Right, and that's what it looks like so far. And then I can combine like terms. There we go. So that is my equation for of the towers. Okay, so I'm going to look at the next one here. So this is the equation for the stairs, this is the equation for the towers. Now I can simplify this also. I can distribute my n here. So I have n squared plus n over 2. I can also rewrite this as, let's say, 1/2 n squared plus n. And then I could distribute the 1/2, also write it as 1/2 n squared plus 1/2 n, half to 2, 1/2 n. 1/2. It's supposed to be a 2 down there. Okay, there we go. So this is my equation. So this is all the same. They're all equivalent, right? And this is my equation for the towers. Now notice I have a degree 2 for each of these. This is a degree 2. This is a degree 2. So these functions, remember, if we have a function that has, like, let's say y equals x, this is a degree 1, even though I don't see the 1 up there, so that makes it linear. If I have x squared, this this exponent lets us know that we have a quadratic equation. Okay, if we have to the third power, we have a cubic, because it's to the third power. Okay, linear, you just have a line, right? Quadratic means we have something that's U-shaped. A cubic can look something like this. And then we have an exponential function, which looks like this. Okay, it's flat, and then it goes up very quickly. Okay, so those are the 3 functions. So knowing that we have a degree 2 polynomial here, that means it is a quadratic. All right, so knowing that these are all quadratic. This is the one we found for the circles. This is the stairs. This is the towers. So which one of these patterns is growing the fastest? I know here it says, is the circle pattern quadratic equation faster or slower than the towers? Well, we just gotta look. These are all squared. This is about the same if we're just looking at that. This we square and then we cut it in half. So that's already, I'm already gonna say this is smaller. And here we have these two first terms are the same, but then we're adding something else here. This one we're subtracting something. So out of all of these, which one would be faster? Okay. All right, that's it for today. Bye.